About 2 weeks ago, I began the paperwork for our 4th patent in relation to DNS and filtering DNS. That is absolutely not what I'm allowed to talk to you about today. IP would probably yell at me if I were to do so. What I am going to chat to you about is our first patent. And this is something which we patented about 2.5 years ago now. And it is just coming to bear and is now a feature in the product as of about 2 weeks ago. So my intent today is to really kind of give you a little bit of a background on this feature and why it is so relevant and actually so cool. And then at the same time do a demo of this feature on someone else's network, ideally, and just make it work and really illustrate why this is actually a cool thing. And I have learned to my detriment that demoing something live like this doesn't always work, so let's see how it goes. All right, so in order to do this, I do need to give a bit of background on DNS. I know that we all deal with and work with DNS on a day in, day out basis, right? It's kind of fundamental to everything we do. But finding a little bit of perspective on that allows me to set the context for why it's changing, what's actually happening. There's some real challenges that we're having to deal with from a DNS perspective, and maintaining control is harder than it ever has been. That's courtesy of encryption. Honestly, I mean, we do not have the ability to lock down DNS like we have in the past. And we're actually going to basically regain control courtesy of this feature. I'm also going to spend a little time on DNS protection. DNS protection is a DNS filtering solution, fundamentally. And what that means is you are protecting your users by choosing whether or not to provide DNS resolution for a specific site, like a malware site or something like that. But it goes a lot deeper than that. There's so much more you can actually do with it. That's just the kind of the fundamentals of it. From there, it's time to demo. And I'll bring it up on my laptop, and we'll explore exactly what that looks like. Because when you lose control of DNS, you end up getting some really interesting problems. It can make life much more challenging than we would like. Okay, so let's look at DNS. DNS is another 3-letter acronym. Anyone know any 3-letter acronyms in this industry? Yeah, everyone groans a little bit. This one, though, is really fundamental to everything that we access on the internet. This is more than, hey, I want to go to a website, www.webroot.com or opentext.com. My browser needs that IP address in order to display the content from that web server, right? That's what DNS translates. But it is far more than just an individual website or a browser. Every process, everything that we access. If I use Teams, if I'm using Outlook, if it wants to phone home, if it needs to be able to connect in, if I have a camera on my home network, it's using DNS to be able to get updates, to be able to phone home, to be able to convey that. In fact, it's integral to everything that we touch, access, and do. And we forget about it because it's absolutely transparent. And the other thing we don't realize, too, is it's old. Well, is 40 old? I hope not. The problem is it's actually just turned 40 this year. It's going through a midlife crisis. It is fundamentally shifting, where we're actually seeing a change. Now, if you're familiar with DNS, because it was created 40 years ago, it was built for performance. Clear text, UDP, not to get too technical, which means we really don't have any control over it. Have you ever been on a network where your DNS is always going to the ISP and never to where you've actually specified? It's because we don't have any control over it. It's actually really problematic. What we're seeing now is a fundamental shift in DNS. We're seeing this a change to encryption. The one that's being used predominantly is what's called DOH. It stands for DNS over HTTPS. It's another protocol that's hiding in port 443. The first one that I remember running into back in the early days was RPC over HTTPS. Does anyone know what that one's used for? Outlook tying into Exchange server. That's when hosted Exchange became a thing. So it was one of those protocols that got wrapped up in HTTPS. And it makes a lot of sense when you think about what it's doing, right? Whenever I connect to an HTTPS site, a banking site, I'm looking at the certificate that's associated with the site, verifying that that certificate is actually that site, and then all that communication is now encrypted. I want to do the same thing with DNS. I want to be able to specify my DNS server, encrypt all my communication, and be sure that that is the DNS server that actually is fielding my response. That makes a whole lot of sense. Additionally, if I can run it over port 443, it's going to go because people can't block port 443, right? If I, on my firewall, show off 443, I'm not going to have access to the internet. Fundamentally, every site these days is encrypted, right? So DNS is going this way. This isn't something which is going to happen. This is something that has happened. Mozilla Firefox, if you install it in North America, it enables it by default and will go to Cloudflare. regardless of what you've configured on your operating system, regardless of what you've received courtesy of the network via DHCP. Yeah, okay. I don't know if I love that. It is optional. You can turn it off. I have a degree of control, but it's one of those things where all of a sudden I'm beginning to see the ability for any process to be able to do this by itself, not just the browser. What else are we seeing? We're seeing it with Apple. Chromium supports it too. Microsoft. Did you know that Microsoft actually supports it natively? Windows 11 Server 2022. This isn't something which is coming. This is something which is here. And I'm going to be honest with you, it's going to make it very difficult to control because I can't see into my HTTPS packets. Now let's say I have a firewall and I'm decrypting all of my HTTPS communication. It's fraught with problems. I need a really powerful firewall to do it right now. And it's only when I'm behind the firewall. What happens when my users go home, when they're working from a hotel, when they're at an event? How do I control and look at their DNS there? I can't lock that down and manage it. All right, so let's look at DNS protection. DNS protection, as I said, is a DNS filtering solution. It does this in a couple ways. The first way, and this is the easy way, is it looks after the network. So if I were to configure this for your network, I would update your router, your firewall, your AD DNS server, and I would point your forwarders at our resolvers. Because we can see the IP address that's actually making that DNS request, we can filter it. And hereby, we're actually going to not provide the IP addresses of bad things or things that are maybe inappropriate. All right, so a great example is crossing off things from that address book analogy. I'll give you an example. My daughter is learning to drive. Actually, she's learned to drive, and she's now going out into the world. If I could give her an address book of everything that I want her to see and cross off everything that I don't want her to see or be able to go to, that would be really good as a father perspective. She would be really thrilled if I did that. But, I mean, you can understand where the need comes from, right? If I can not give you the IP address of a malware, if not give you the IP address of a CNC, a command and control, or a botnet, then I don't have that exposure, I don't have that risk. If I can't get to the site, I'm not going to get harmed. That is a really cool layer of security. Now, that's the network. How many people are never leaving the office and always working from the office these days? Yeah, me too. In fact, I almost never go into the office. I'm either traveling or I am working from home, but I mean, I am rarely behind the corporate firewall. And if I do VPN in, I turn it off immediately because I don't really like work seeing where I've gone, right? So therein lies a challenge of how do I protect a user like me? Filtering DNS with an agent is the way you do that. So I can actually intercept and manage and control, and better yet, encrypt all of your DNS requests using the WebRoot DNS protection agent. Great, that makes a whole lot of sense. Now, the other thing which we do, by the way, if you haven't used this solution, is we make it super simple. I had a conversation with an analyst, it was actually earlier this year, and they referred to DNS as the low-lying fruit from a security perspective. This is because it can be implemented transparently. I can change your DNS settings and filter your DNS, and you won't notice it. Now, if I make you use two-factor authentication, are you going to notice this? And your users love two-factor authentication, right? Every one of them really enjoys it? Okay, what about training? All your users say, please, can I have more training? I want to be more secure. This actually can be done without inconvenience. In fact, they won't even notice. I have it running on my home right now, and I can filter and adjust and actually send my daughter to the Google Safe Search version of Google, and she doesn't even realize it. And I can filter all the DNS requests for all of my devices. So this can really go through in a very simple way. Now, it's always DNS. This is one of those things that we run into all the time. When we have problems with DNS, we have problems with the network. If you have DNS break and Active Directory causes issues, it's almost invariably DNS. Do you see last month that Squarespace went down? So they went down for a whole Saturday, and that's credit card processing. Do you know why they went down? They misconfigured a DNS server. And the problem with it is it's really challenging to track that down. It's just one DNS server. So some of the times it was working, some of the times it wasn't, right? Figuring that out and where to actually go to fix that is a royal pain in the neck. Now, let's say that I had better control of my DNS for all of my endpoints, and I knew exactly what resolvers they're always using. Suddenly, DNS is a whole lot more controllable, a whole lot easier to manage. I'm beginning to allude to what DNS leak prevention is actually going to do for us. Okay, so control beyond the browser. The only time I ever use DNS is when I'm on the browser, right? Right. In fact, it's every process, everything that we touch. And this includes malware, viruses, they like the dynamic nature of DNS as well. There's a lot of power to actually leveraging that. So it's so much more than just, I'm going to insert an extension in the browser and actually do some filtering. I want to look after everything that's actually on that operating system. A browser is just a process. It's just an application that's running. So we can actually go much further and much deeper with something which actually captures everything on that system. The other thing, too, is we actually have to, in order to protect a system correctly, we have to look after encrypted DNS. Not only should all of our DNS requests always be encrypted so we have full control and we know the server that's resolving it, but we don't want encryption to happen behind the scenes, independently of what we've configured. So I, as an admin, if I have configured a DNS server via DHCP on my system, I expect it to be honored. Because guess what? Now I know that I'm going to get the DNS resolution that I expect. But with processes potentially able to use encrypted DNS outside of my control, I have a major problem that's developing. Okay, so have you guys ever heard of, and actually I find this instance kind of, it really illustrates one of the reasons why I want to go further than just a browser. You guys ever heard of a dropper? This is a really interesting concept. The dropper is the first file of an infection that's dropped on the system. And it's oftentimes not bad news. This is the friend that you invite to a party who, everyone kind of likes, he's actually reasonable, but it's his friends that he subsequently brings in and lets in the back door that absolutely trash the place. Those friends are the ones that case the joint and look for information to steal, the ones that encrypt all of your files, the ones that basically exfiltrate data, causing you all the problems with ransomware. SmokeLoader is a ransomware. And all the pieces that it's going to bring in can be blocked by DNS. So if I am filtering DNS on the entire system, I'm not just looking after the browser, I'm looking after the processes as well. So you can see there's 12 different DNS lookups. If we block all of those, then basically the back door stays locked. No friends come in, no data exfiltration happens, no harm done. Endpoint, whatever AV you're running, can catch up, finally clean up this thing before it actually does any serious harm. And let's face it, what we're really scared of is data exfiltration. I can recover my files. I have backups, right? We all have really solid backups these days. We've been forced to because of ransomware. But now ransomware scares us more because it's stealing our information and holding it hostage. And it gets a little bit scary. Now, I like the kind of the SmokeLoader reference just because it really gives me an understanding. Those are the different countries, by the way, that those domains actually corresponded to. This is a lookup of one of those domains. I can do every single one of them inside our intelligence. So our intelligence is called BrightCloud. It is a machine learning-based ML, so AI, whatever we're calling it these days. It's not generative AI. Our marketing department really wants us to call it generative AI. We're not generating anything. But what you'll see is the ability to identify domains. We actually process 500 billion objects a day with machine learning. We've been doing so since 2006. This is by far the best intelligence that we have out there, especially when it comes to filtering DNS. What you get when you have really good intelligence, by the way, is we block phishing sites that have only been up for 4 hours. Those are the ones we're worried about, right? We don't block a site that was bad news because it was a corrupted WordPress site 6 months ago. That creates nuisance tickets and headaches for us as admins. Right? It also annoys the user as well. Good intelligence means it works and protects you without getting in your way. It's exactly what this does. Oh, here's the email, by the way, of exactly what the ransom looked like. Don't worry, you can return all your files, right? I have full confidence that after I pay the ransom, they're never going to exfiltrate, or never going to share my data with anyone. They're going to give me all my files back. Yeah. Ransomware is just a nuisance. But this is an example of another tool, another layer of protection that can really look after you. Okay, so I've just given you the reason behind DNS protection, right? Now, what happens if I'm filtering all your DNS requests and yet I'm missing some? That's really problematic. All of a sudden, I can't report on it, I can't filter them, and I can't protect the user. We saw this as a problem with DNS filtering in general, and this is exactly where we went. We actually built a solution, a feature that's not a cost feature. This is something which is built in that allows you to lock down DNS. This way, you can block port 53, which is your typical DNS request, right? I can basically a firewall, if you will, on the agent itself that controls that. Port 853 is DNS over TLS. DNS over TLS is another encrypted DNS solution or protocol. It's kind of like the Betamax. It is the better solution that nobody's using. All the DNS people will actually cringe when I say that, but everyone has really gone to DNS over HTTPS. The problem with controlling and managing HTTPS is you have one of two ways of doing it. You either decrypt, inspect, and re-encrypt, which is fraught with problems on all HTTPS traffic to do that, or do what we're doing, which is block connections to port 443 to known DOH providers. So when you run this on your networks, on your systems, you regain control. DNS resolution has to be achieved through our agent. Very elegant, very simple, and very easy to do, just a feature built right in. And if you ask me, this is table stakes. I don't believe that you can do DNS filtering right unless you're doing this. This is also why we filed a patent almost 3 years ago to be able to do this. All right, now for the bit which is fraught with errors, problems, and challenges. What I'm going to do is actually show you exactly the way DNS leak prevention works. And ideally, it'll give you a good example of what's possible here. So let me close out the presentation. Okay, so what I have here is a tool that my developers built me so I can actually show you without having to go into our web console and turn this stuff on and off. That screenshot that I showed you previously is actually of the console and exactly the settings, but it takes just a couple minutes for that to update on the endpoint. This is instantaneous, and this is why I'm actually using it. So if I look at this, what you're going to see is it says status filtering. So I've installed our agent. The agent is an 8 meg MSI, so it installs, done. It's really, really light, fast, uninstalls just as quickly, really elegant and simple. It shows me that it's filtering. All right, so let's verify that it's actually filtering. I'm going to open up a browser, and I'm going to put my user hat on. Now, what websites do I like to visit as a user in London while I'm actually away presenting? Let's see if we can find a good dating site or my favorite dating site while I happen to be in London. So www.clowndating.com. It's blocked. Okay, so HR seems to disagree with my particular dating site preferences and will not let me get there right now. It makes logical sense, right? We want to keep our users away from bad things. The dating site's not necessarily bad, but some of the sites can be questionable. It's not appropriate from a work perspective, right? Now, what happened here? Why did I get a block page? It's actually pretty simple. What happened is we looked up the category that Clown Dating came in, which is a dating site. And instead of giving me the IP address, or my browser, the IP address of clowndating.com, it gave me the IP address of our block page. So we're displaying something different that's not going to expose a user to the content or the thread. Now here's the problem. As a user, I happen to be smarter than most people. I can figure out a way around this. Maybe it's because I don't feel that old anymore, and maybe I'm just more in touch with a teenage boy that I used to be. But I can see that this is DNS protection, right? Let's think about this for a second. If I were to open settings and go into DNS settings and enable DNS over HTTPS in the browser to go to Cloudflare, what's going to happen? Exactly. I'm now going to go through 443. The process is going to create a direct connection to the DNS resolver. Hey, I am no longer filtering DNS. So I'm really anxious to get there. By the way, someone swiped right on my clown profile. Let's go ahead and open that. Oops, I must have hit something wrong. I made it. All right, so if anyone's wondering what the slogan is here, everybody loves a clown. Let a clown love you, which is absolutely terrifying. So now I've circumvented DNS. That is actually a major problem, right? Because I can't see that. It's now running over port 443. As an admin, what do I actually do about that? How do I regain control of DNS and stop processes hiding from my filtering solution? All right, let's go ahead and close out Clan Dating. Do not need to see my profile right now. And what I'm going to do is actually configure leak prevention. But first, let's do this. I have a test for leaks button here. Test for leaks basically is a utility that just goes through and queries available DNS servers. just lets me know what's available. It tries Cloudflare, it tries Google. What's interesting, by the way, the unique thing in this network is it appears port 53 is actually locked down to select solutions because port 53 is easy to block and easy to manage. But you will see that 443 and 53 TCP is available. So interesting. That's how I was able to circumvent it, right? I was able to get DNS resolution and I was able to circumvent it. All right, let's turn on leak prevention. Again, this is something that you do normally in our console and by policy. So I'm going to enable standard DNS, DNS over TLS, and DNS over HTTPS, and hit OK. When that turns green, it means that that is now locked down. We've just enabled the DNS leak prevention as a firewall on this. So first thing I'm going to do is test for leaks. It takes a little longer for it to fail, but you can see now that none of those requests are actually going through. So, coming back to my clown dating example, what happens when I go to clown dating? Anyone know what actually happened there? What happened behind the scenes? It tried to connect via DOH. 443 was blocked, unable to connect. Now there's no DNS resolution when that is enabled. As a user, I have to go turn that back off again and go back to using DNS that's provided by the operating system. Now, we have amazing intelligence to be able to block all of those DOH providers. This sounds like a really simple, easy solution. It is. It wasn't super simple to implement. We really had to do a lot from an intelligence perspective and a gathering perspective. But this makes it possible for us to gain control of DNS again. And this is beyond whether the browser can go out and access something. I mean, that's the obvious use case, but being able to stop a process from being able to exfiltrate data, being able to communicate and phone home, again over port 443. Now, I should also quickly just spend 2 minutes touching on a couple of the other things that we have coming, because we are innovating like crazy. We are absolutely pushing the bounds of what DNS should do. The next thing that we're going to do, and this is another patent that we filed, by the way, this was number 2, is begin to look at your DNS requests. So one of the things you can do with DNS is make a unique DNS request of a domain, and the very nature of DNS is if it's a unique one, it's going to go all the way home. It's going to go back to that authoritative server. You are effectively phoning home built in with the DNS policy, DNS protocol. It's called DNS tunneling. One guy at RSA did a proof of, as actually Black Hat, I take that back, a proof of concept VPN using DNS. What are we all scared of? Data exfiltration. What are we not paying attention to? You guys look at all your DNS requests and make sure nothing's going out, right? Therein lies the problem. I want to know and I want to stop it. I've actually spent the last 6 months looking at DNS requests and figuring out what that pattern looks like. You wouldn't believe how much communication, including Microsoft, by the way, that goes out over DNS. So the next feature after we have full control of DNS is going to be able to block tunneling as well and stop data exfiltration from all your endpoints regardless, not allowing it through DNS. I've actually seen viruses use DNS to phone home, command and control to communicate with, basically to do the damage that they do, and it's all transparent and built into something that we actually have in our networks that's designed to do just that. So some really, really cool things happening behind the scenes. I can't talk about the third one yet, because that's going to fundamentally change everything we're doing from a DNS filtering perspective, and I'm not allowed to, but I'm really looking forward to it. Hopefully next year, I'll be talking about it in the same venue. All right, let's jump back in. We can make that work. And that actually ends up wrapping up my presentation. So I'd like to leave you guys with 3 different thoughts, 3 takeaways from this. The first is that you are missing things from a DNS perspective, either from a logging perspective, either from a filtering perspective if you are filtering DNS, and you're missing a huge opportunity there when you actually aren't getting all of those DNS requests. You have things that are sneaking by. And DNS filtering is fundamental to your security, right? I mean, being able to add another layer transparently can make a meaningful difference, especially when you have things like that. The third thing, and it's not that there's a really cool dating site that you haven't tried yet. The third thing is that we are innovating like crazy. We are doing some things with DNS that are really going to change it and make it easier and easier. And it's going to be designed for this space. This isn't something which we're building for the enterprise. This is something we're building for MSPs and SMBs. We know you guys need the tools. This is an elegant one, and it's really cutting edge. Now, I would love to explore questions, thoughts, Are we going in the right direction? If you want me to kind of delve into this further and do more tests, and no, I'm not willing to try other interesting websites, at least not while I'm on stage. But if you'd like to see what is going on, I can actually get into it really under the covers and show you. You can come back up to the booth and have a chat with me. If you're interested in finding out what it takes to implement DNS for yourself, which is such an easy thing to do, we have lots of people up at our booth, including Emma, who's in the back. It can help us kind of figure out what that costs and what it takes. But I mean, I love to explore this stuff. I hate to say it, I'm an absolute DNS geek. I spend a lot of time reading about it and working with it, obviously developing it. So if you guys have any questions, anything that I can provide, I would love to be able to have a conversation. Or if I traumatized you all with clown dating. Yeah?
So you mentioned it on the DNS leak prevention.
Yep.
Is that just looking for DNS-based activity, or is it going for a known list of DNS servers?
So,
Say for IS malicious actor may just stand up a DNS server, for example, and configure my malware to use that after.
so actually a really, really good question. The first thing we're doing is think of it as a firewall. What we're actually doing is just blocking 53. That's step one, because that's going to be the majority of your DNS requests. Then we're actually going to block port 853, which is your DNS over TLS. And by the way, this is the reason that DNS over TLS hasn't taken off, is because it's too easy to shut down. You can just block it. The reason that DOH is so successful is because it's running over 443, which is so hard to control, and it's encrypted, and everyone just lets it through. So the way to do that is to have really good intelligence and being able to shut down. So the way we're not actually inspecting those, we're blocking access to the DOH providers. And yes, there is a dynamic nature to it. So you'll find that it is incredibly effective. And because of the way we're actually looking, we subscribe to lists as well as generate the intelligence ourselves. I think we have some of the best intelligence from a DOH perspective in the industry, and it's only getting stronger as this solution becomes more and more available. So really, really good question. Did I field it correctly? Yeah?
How do we explain to our customers in layman's terms what the risk of DNS filtering actually is and why they need to implement a solution?
I think the first thing is that is a meaningful layer of protection. What we're looking for is something which you can implement without annoying our users. And this does just that. The number that I've seen is a 27.1% real-world reduction in malware. That means that it's another layer. People are going to click on things. We want to help them when they do, right? That's the fundamental piece. Now, we do have the ability to control content as well. They usually like that because it improves productivity, and it keeps people like me away from inappropriate sites while traveling. So those are the primary drivers. The productivity is a great conversation, and then the enhancement in security. The third, and most people don't really think about this, is the reporting. I can show you what went where and when. And that includes, like, if you have been compromised, or if I have something which is reaching out to a command and control server on my network or on one of my devices. I'm like, what the hell is going on? What has AV missed? I have visibility now that that's happening, and I can be proactive rather than I've just lost a whole lot of data. So those three things layered together makes it really meaningful. The biggest thing, too, that you will like as an MSP is it's easy. This is not something which is painful to implement.